We are discussing. So HANA database administration part we are discussing. As part of this one, HANA Studio is one of the monitoring tool, Eclipse-based monitoring software, which we have to install in our desktops. So then we have to add our HANA systems. Then we can do the monitoring here. We can do the monitoring from here. So in the monitoring side, what we so here the any issues, CPU, memory, space, database level tables, where it is available. So all those things we are discussing, right? The same time, there is a one more important topic is here. It will happen in the internally, that is called the delta merge and the save point interval. Delta merge and save point interval here. So what is mean by delta merge operation? What is mean by delta merge operation in the HANA databases? Delta merge operation in the HANA database level here, right? So here delta merge operations means delta merge means, so actually this is the internal topic. Normally system internally will perform these operations, delta merge operations and save point interval. System internally will perform these operations here. So delta merge and save point interval here. So delta merge, so what is mean by delta merge here? So normally SAP system means, so it's a SAP HANA means it's a in-memory database. It's a in-memory database here. So in-memory means, suppose example, this is the main memory. This is the main memory, and these are the file systems. Operating system level, we have the file systems are called the slash HANA data, then slash HANA log folder here. Slash HANA data and slash HANA log folders. We have the this type of file systems are available here. This type of file systems are available here. Slash HANA data, slash HANA log folder here, right? So delta merge, save point interval. So first of all, delta merge. Delta merge means very important. The main memory is divided into the two parts here. One is the DS and second one is the main storage here. One is the DS. DS means delta storage. So every table we have the delta storage and main storage we have here, DS and MS here. So main storage and delta storage here, right? So here what will happen here? What will happen here? So HANA will store the data into the in memory. So which is means it's a RAM memory. This is the disk level. Disk means file system level. This is available here in memory. Disk level here it is, right? So what exactly happens here? What exactly happens here? So what exactly happens here? So whenever what exactly happens? So whenever any data is coming to the HANA database, first it will store the data. First it will execute the query. The queries will be executed in the here in the delta storage. The queries will be executed in the delta storage here. Why? Because delta storage, main storage here. Inside of means the main memory, entire main memory, how we will do the partition of the house like master bedroom and small bedroom. Same way here, the main memory is divided into the two types here. One is the DS delta storage and second one is the main storage here. DS and MS main storage, it will be divided into the two types here, right? So here what will happen here? So whenever any data is coming from the application, right? Normally data will come from the application only, right? Either SAP application or the third party, the data will come inside of the system, right? Either MS, DS, anything like any data which is coming here, it will come to the, so it will come to the folders here. So first data will be stored into the DS. So here, why? Because why it's not in the main storage directly here. So here the delta storage, it will store it. So delta storage is optimized for the read plus write plus compression mechanism. data will be compressed into, when it comes to the main memory, data will be compressed. There is a 10x compression technique will be used by the HANA. So automatically the data will be compressed. This is one of the advantage of the HANA database here. So whenever any data is coming from here to anywhere to HANA database, it will store the data. Means all the data it will be executed. All the data, the calculations will be executed here. All the data so will be executed here, right? It will be executed in the delta storage here. So once the transaction is committed, if the transaction is committed, then only this will go to the main storage. This will go to the main storage here. So this procedure, moving the data from delta storage to main storage, is called the, moving the data from delta storage to main storage is called the, so delta merge. Delta merge means moving the data from DS to MS is called the delta merge operation. Delta merge operation here, right? Data will be moved from the DS to MS here, right? This procedure is called the, so delta merge operation. Sir, why can't we directly store the data here? Why? Because main storage is not optimized for the write, only read plus compression mechanism. So also the previously the committed data, our accounts, our tables, valuable data, then the costly data, everything will be stored into the here. So that's why directly the queries will not be executed. The data will not be saved directly into the main storage here. Instead of data, the queries, the calculations, everything will execute into the, in the delta storage. Delta storage level, it will execute it here. So then the data will, so once the transaction here, if condition means data will be stored here, then when this will go to the main storage, if the, if the transaction, if the transaction is committed, if the transaction is so committed, the transaction is committed, then data will go to the main storage. If the transaction is committed, the data will go to the main storage here. This procedure is called the, so delta merge procedure. This procedure is called the delta merge procedure. Now you got it right. So directly any data will not be saved directly into the main storage. Why? Because main storage is not optimized for the write. Also, main storage contains the actual data. So if any data directly coming to the here, it may impact the existing data also. It may clash the existing data also. So to avoid this type of issues, so what will happen in the every table, first data will store into the delta storage. Then once the transaction is committed, it will go to the main storage here. So this is called the delta merge. Means the delta storage data is merging with the main storage once the transaction is committed. Means you are doing the payment, you are trying to book the ticket in the IRCTC, then the transactions that will be executed here itself only. Then you are booking the ticket, you opted the seat, then you went to the payment gateway, you selected your bank account, your transaction, then your transaction is committed, means successfully completed, then only your data will move to the main storage. Till then, you are login to the irctc.com, then opening the bus ticket, train, then doing the all the other work, other tabs, everything before committing, before the transaction committing, your data will be saved into the delta storage only. Once the transaction you done committed, then data will go to the main storage. It will sit into the database table level, database table level, it will sit into the here. So this mechanism is called the delta merge mechanism, delta merge mechanism, delta merge information. So then once the data received to the main storage, then same copy of data will go to the, same copy of data will go to the OS level file system. Sir, previously you informed me like a HANA is a in-memory database. All the data will stores into the in-memory level only, not the disk level, in memory level itself only, right? So what is the reason? What is the Yeah, sorry guys. So here slash ana data here slash ana data. So data will go to here, from here to here, then from here to here it will come. Why? Because main storage RAM is the volatile memory. Normally there is a one naming one disadvantage for the RAM is here. RAM is the volatile memory. Volatile memory means it's a temporary memory only. RAM is. Once you done the system restarts, what will happen? All the data will be all the data will be deleted from the RAM memory. Sir, we have the 1 TB data. Hana is storing the all the data in memory itself only. Whenever you any RAM crash, any memory crash, whenever you stop the database, whenever the hardware crash happens, so your RAM will be RAM, whatever the data is there in the RAM, all will be deleted, right? Yes, that's true. All the data will be deleted here. Whenever you do something, all the data will be deleted from the your memory. So then again, then why sir is my data loss? No data loss here. So why? Because so RAM one copy of data here it is writing, then same copy of data every 5 minutes, that is called the save point interval. Save point interval will happen every 5 minutes. So whatever the data is received here, after the 5 minutes, it will go to the your data folder. Data folder at operating system level data folder it will go. Right? Operating system level, the data folder it will go to the here. So in this case, we don't have any data loss activities. Right? So why? Because even the RAM is gone, even the system is down, entire data will be gone. Right? So then how again you are when you are starting the HANA database, how you are getting the data here? So how you are getting the data means again, so whenever you are starting the system, all the data will be reloaded again from data folder to again disk, data folder to main memory. So again, whenever you are starting the HANA database, data will be reloaded from data folder to and main memory. That will happen, right? Reverse sync. So which means, so every 5 minutes, so HANA is responsible to store the data is only here. Then after that, save point will happen. Every save point will happen every 5 minutes once. Every 5 minutes once, data automatically will move from main memory to your disk format here in the data folder here. Okay, data here it is, data is available, here also data is available. Then if the RAM is crashed, then what happens? Nothing will happen, right? Why? Because we have the data already at the file system. So whenever you are starting the HANA database, what will happen? All the data will be reloaded to the main memory. So we want, let me show you here. Is the HDH, yes, HDH. So HDH info, right? So this database is down, right? Then you can see used is the 0, right? Used memory is the 0 here. Means nothing, no database is up, which means RAM is the 0 now. There is no memory in the RAM, right? There is no data in the RAM. So whenever you start the HANA database now, right? You are starting the HANA database now. See, let's see what will happen. You are starting the HANA database. Now what will happen? Whatever the data is there in the data folder, everything will be loaded to the main memory. So once the data is available in the main memory, it will show there is a used size. There is a HANA used size is the main memory size is the some 8 GB, 9 GB, it will show here. So if you want, let me take the one more duplicate session of the HANA database here. So then I will show you the logs. I will show you the logs here. CD trace directory, voice level file system, right? So here we go to the index server. Why? Because all the data will be loaded into the index server only, right? Then if you check the index server log files here, loads, unloads, then loads. So loads. So here you can see the tables will get loaded here. All the tables will get loaded here. Now you can see, so tables. So now we are in the heap allocator table, right? So let me see. Still it is starting mode. So which means the tables are getting loaded. The tables data, whatever the data will get loaded. Just wait and see. You will see the log will get updated. The log will get updated into the systems here.
Sir, I have one question here.
Yes.
So by default, this column tables will be like column-based table will be loaded into memory, right? While starting the database.
Yeah. I will explain that one as well. So which one will be loaded? We have, while starting the HANA database, that is the next point I'm going to explain, right? So now you can see once this is progress happens, then I will explain. Just to give me a minute, because it will update. It will update the data. So there is a loads will happen. So here what will happen, the data will be loaded. The data will be loaded first here. So which data will be loaded first? Which data will be loaded first here by starting to the here? Why? Because in the HANA database means here row store tables, column store tables are available, but which data will be loaded first? So all the business data will be stored into the in the column store tables only. So here HANA, normally we discussed in the starting term, HANA is a column oriented columnar database. It has only columns, means all the business data will store into the column level. But HANA has system tables also. Some of the row store tables are system tables also. Those are the some configuration tables. HANA configuration table. It will store the data into the configuration tables also here. So in that case, so we have the row store tables and column store tables also available. So here loads, you can see the loads are getting updated here. Loads means the data is getting loaded. Now you can see here. So it is getting updated, right? See here, one more function, one more table got updated. Means data is loading into the main memory. Data is getting loaded into the main memory here. These all are the tables on. See here, data is getting updated. See here, it's all are updated, right? So here, so which data? Let's leave it. So the data is getting loaded. Which data is getting loaded first here? The first of all, while starting the HANA database here, the first of all from data folder to here, first of all, the system tables will be loaded first. System tables will be the loaded first. Why? Because system tables contains the configuration, which table has to place where configuration will be. So the configuration tables has to be loaded first. Then secondary indexes will be created. Index to speed up the table. Every table there is an index. Secondary indexes will be created if required, right? Then the third one, the column tables, column tables loaded the next. So first two system tables, then column tables will be loaded next. Then the fourth point, what will happen? Then roll forward. Roll forward will happen. Roll forward will happen. Then roll back will happen. So these are the sequence of steps will happen when the HANA is getting started. When HANA is getting started, the sequence of steps will happen here. You can see here. So HANA is completely started here. So then HDB info. So somewhat some data got loaded to the main memory. Whenever you use the free -g, it will show like So some used memory is the 7 GB. Previously used memory is the 0 GB, 7 GB. What happened during this frequency time here means, so data got loaded into the RAM memory. The data got loaded into the RAM level here. So that's why you can see the memory got increased here. Memory got increased into the systems here. That's what happened in the systems here, right? So column store tables will be loaded, then roll forward, then roll back here. Roll forward means roll forward. Roll forward means, so the data will move from here to, so roll forward. Roll forward means whenever any sudden crashes, in a sudden crashes, data is committed but not stored into the data folder. In that case, the data will go forward, go one step before, then will store into the data folder. Why? Because the data folder contains the actual SQL data, committed data. So it will contains the here, right? So then roll forward. So then the statements which are not committed, the transactions are executing, but whenever you are going to the payment mode, it's an outside example. So what will happen whenever you're going to the payment mode, when you're doing the payment, but immediately the server is down, your payment is not completed, then the transactions will go roll forward, roll back. It will go roll back here, previous status, original status here. Roll forward means it will go forward, it will save into the database level, you will get the ticket confirmation. So that is called the roll forward and roll back statements here. Roll forward and roll back statements here. It will happen here, right? So that is the roll forward and roll back. This will happen whenever you are starting the HANA databases, then this will happen. So whenever you stop the HANA database, again, whatever the data is there here, all the data again, it will unload from main memory to disk. When you are starting, it will load the data from data to main memory, unload from here to here, right? That will happen in the system here. So we can see it here, we can see it in the systems here, right? So there is a save point also, we can observe it here. So save point. So save point mechanism here. So whenever you open the HANA index server trace here, maybe you can use the tail command or cat command, right? So then here you can see the save point here, save point mechanism. So now after the HANA started 958, the save point, the current save point version is started here, right? 933 save point version is started. So 958 is the current save point version is started after the 5 minutes. So if you wait for 5 more minutes, means 2203 next 5 minutes, right? One more save point will happen. One more save point will happen. The version of the save point number is the 934. One more save point will happen here, right? Which means the save points are happening. Save point means copying the data from main storage to disk. Disk means the data folder. That is called the save point. So by default, the save point interval is the every 5 minutes. Every 5 minutes is the recommended one from SAP. So you can make it as it will take automatically. You don't need to do any changes here. Every 5 minutes, the 5 minutes. So here, if we wait for 2 more minutes, not the two more, yeah, if we wait for the 3 more minutes, then the next save point will happen, which means, so here you can see 9158, right? Plus 5. 5 minutes, right? Then plus 5. So what will happen? 303, 2203 here. So now 22 means 1003. Now it's only 959 only. So just wait for 5 more minutes, not the 3 more minutes we wait it, then save point will happen here. So that's way save point. The save points are happening perfectly fine means, so definitely the data will be in the data folder level. So we need to check at last save point when was happened. So that data will be in the data folder. But save points are not normally, save points will happen automatically. But save points are last save point are happened yesterday. Man, Ben, today you are restarted means from yesterday 10 o'clock save point happened. Now 10 o'clock you are doing this thing. Then last 24 hours data will be gone. So normally system will go out in that case, but so save points will happen automatically. Save points will happen automatically. That's why to avoid these issues, save point will happen. Anyhow, locks are there. The locks will be applied. So data will be, there is no loss of the data, but save points will happen here. This is about the save point interval. This is about the save point interval. And so delta merge operation while starting, what will happen? This will happen, right? So that is what it will happen here. Now 3 minutes, next 3 minutes. So this will happen. One more save point will happen. You can see the version will change. So it will give the information. So if the data comes or not, it don't bother. So immediately the data will be flashed to the here. When the data comes, so then if the transaction is committed, the data will come to the here. Then once the data is come to the here, next 10 minutes, it will come to the here. So that is what will happen in the internal mechanisms. These all are the internal mechanisms. These all are the internal mechanisms will happen. Okay. This is about the delta merge and save point interval. So normally, if you want to manually perform the merging, if you want to manually perform so that is also possible here. If you want to manually load the data into the memory, you don't want to load the data into the tables into the main memory, that is also possible here. Just if you go to the, so one of the database here, okay. So if you go to the catalog, so where the tables are available under the catalog, so we have the schemas. Under the catalog, we have the schemas, right? So under the catalog, we have the schemas here. So if you go to the schemas here, let's see in the schema, we have any data here. I think we created the one table, I think last time. So let me see. No, nothing is there here. So system, some replication table or something we created. Yeah. So one table we created, right? So what we can do, you can see it here, right click on the table, we have the options. I think 10.3 has happened. Let me check here. Where is the log file? Yeah, 934, right? So 10.3, one more save point happened. In between time, there is a one more log file is happened here. So here save point up to here we know, like 958. So there is a 933, and so one save point is occurred. Now whenever the 10.3 happened, 10.3, there is a one more save point happened here, 934. Then again 10.8, 10.8, 3, right? 5.8, yeah, plus 5. So then 5, 10.8, one more save point will happen. Like this, data will be in the sync automatically. Data will be in the sync automatically here. So here you can see it here. So any table you can take it out. So here this is the, okay, this is the here. Normally if you go to the tables here, normally any table, any business tables, there is a lot of data here. So sometimes what the people will do, they don't want to that much of data. They don't want to data in the, so they don't want to stay that data in the column store. Then what they can do, they can, so they can reload the data. We can just reload the data. We can load the data. So that type of things they can perform it. We can also perform that one here, right? So we can also do that one. We can also do that one. So here math is there. What I can do, there is a data here. custom tables, business tables, column store tables. If you create it, I think I created for column table for one year. Here, go to the catalog. So here in the catalog, so on a cloud, there is one custom table actually. I want to show the options. So why? Because this is the column store table. So what we will suppose if you want to stay that data into the main memory, why? Because main memory already the 9.37 GB is already occupied, right? So 9.37 GB is already occupied here, right? So if you want to unload the data here, I don't want to data should be stay in the main memory. I want to training data. So there is a table here, right? So this is a column store table here. So you will get the option like load into the main memory. So suppose this table performance is very low. Why? Because this is in the disk level. You want to load the data into the, you want to load this table into the main memory. Then you can use the option like load the data into the main memory. Suppose I don't want to data, I want to unload the data from the main memory. Why? Because if the data is there in the main memory, the license also will be used. If you unload it, what will happen? So the data will be in the disk level. So accessing the data from the disk level, it will be very slower because of data will have the, it will be very slow here. So it should be loaded memory first and it will be very slow here. So we can also unload manually, also we can unload it here. Then so manually also we can unload it. Then we can also load the data into disk to memory level also we can load it. Disk to this is also we can load it here. That is also will happen here. If we go to the here, so we can just if we go to the here, so then you can see it here. So perform unload, load. We want to perform the delta merge. Sometimes what happens, delta merge will not happen for the tables. Then in this case, we can also manually perform the merges. So all the committed entries from the DS to the MS will be stored. So which you just perform it here. Automatically, whatever the data is not there in the main storage, this will come to the main storage level. Then from here to here, we can load the data, unload the data. So manually also we can perform it, but that is not the recommended approach. Only only automatic way. Automatic way you can do that one. Automatic way you can do it. You can do that one. Okay, this is about the delta merge operations here. You want to automatic, manual, so anything. So sometimes they may ask you, is it possible to perform the manually? Yes. So right click on the table. So then just there is a options are available. We can, so do you want to export? We can export the table. We want to import the table into the other system. We can also import the table here. We want to delete the table. We can delete the table. So how you want to do? We can also do that one here, right? So that is the one. So we can uh, for these tables, right? So once this is done, so yeah, you can.
Sir, sorry to interrupt. I have one question here. So, how to monitor whether this delta merge is happening or not? You said like sometime it
It
won't
will
happen. So, like how to monitor this, like whether it's
signals
happening
only,
or not?
log file signal only here. It will tell you like
Okay.
entries are not moving, something like that. So it's not happening. So something we will get the changes will not be reflected. How can we monitor means? So we can say whatever you users are application level changes are coming, it's not changing into, it's not coming to the database level. That it's not committing. The users, suppose example, we will move the table with one application level or some transports you moved, but the changes are not reflecting into the database level.
Okay.
Transports mode, but changes are not reflecting to DTB level. Then in this case, oh, delta merge is not happening. Then in this case,
Okay, so anyhow, like this the data will be stored in the main storage after data merge only, right?
no, yeah. First delta merge, then it comes to the from delta merge means
Means
DS
no, not the main this storage. No, sorry, not the main storage. This storage, right?
disk storage.
Yeah, correct. Now got it. Yeah.
Okay, so just